Example 2, Maine Pick 4. In the Maine Pick 4 game, you pay 50 cents to select a sequence of 4 digits from 0 to 9, such as 1, 3, 7, 7. If you play this game once every day, find the probability of winning at least once in a year with 365 days. Now, time interval is a day, and playing once each day results in n equals 365 games. Because there is one winning set of numbers among the 10,000 that are possible, from 000 to 9999, the probability of win is equal to 1 over the 10,000. Now again, another way of looking at this is the following. So if we take a look at the number 1377, that means it's a 4-digit number. So a 4-digit number, we have 10 possibilities here, times another 10, times another 10, times another 10, which would then give us 10,000. And so that's how we're getting 10,000 that are possible. And so the probability of win is then equal to 1 over 10,000. So, with n is equal to 365, and the probability of the win is 1 over 10,000, we need to take a look at the conditions. Well, the conditions of n, which is 365, is greater than or equal to 100, and then we need to check n times p. So, if we take the value of n, which is 365, and then we're going to multiply that by 1 divided by 10,000. And you can see we get 0.0365, which is less than or equal to 10. Therefore, they are both satisfied. So we can use the Poisson distribution as an approximation to the binomial distribution. Now, if those didn't apply, then we could not use the Poisson distribution. Now, we first need to find the value of the mean, which is the following. We know from this part here, the mean is equal to n times p, which is 365 times 1 over 10,000, which is what we did, and we got 0.0365. Now, having found the value of the mean, we can proceed to find the probability of specific values of x. We want the probability that x is at least 1. We will use the strategy of first finding probability of 0, which is the probability of no wins in 365 days. We find the probability of 0 by using x is equal to 0, the mean is 0.0365, and the value of e is equal to 2.71828 as shown here. So we plug in the value of the mean, which is 0.0365 to the power of 0, times 2.71828 to the power of negative 0.0365 divided by 0 factorial, which is going to equal this, anything to 0 power is 1, times we get 0.964158118 divided by 1, and then rounding that number to 4 decimal places gives us 0.9642. Let's just go ahead and verify this on our calculator. So if we put in parentheses the mean, which is 0.0365, and then close the parentheses and raise that to the 0 power, and then we're going to multiply that by 2.71828, and then that's to the power of the mean, which is negative 0.0365. Press enter, and then we get that value. And then since we're dividing it by 0 factorial is 1. And again, rounding that to 4 decimal places gives us 0.9642. So the probability of at least one win can then be found by subtracting that result from 1. So we're going to use the Poisson distribution as an approximation to the binomial distribution that we find that there is a 0.9642 probability of no wins. So the probability of at least one win is equal to 1 minus 0.9642, which gives us 0.0358. Now, if we use the binomial distribution, then we get a probability of 0.0358. So the Poisson distribution works quite well here.